Hello, and thank you for joining us. My name is Beth Carlton, and on behalf of Cumulus Networks, welcome to the Open Contrail and Cumulus Networks webinar, Accelerating SDN Applications with Open Source Network Overlays. Presenting today will be Jennifer Lin and Meena Shankaran. Jennifer leads product management for cloud network services in the Open Contrail team at Juniper Networks and participates in several open source industry efforts to drive market adoption for cloud and for network functions virtualization. Meena heads ecosystem software and solutions at Cumulus Networks. She has extensive breadth and expertise in the data center space combined with business and technical acumen. This webinar will last 30 to 45 minutes. At the end, we will answer a few questions from the participants if time permits. During the webinar, you have the opportunity to ask your own questions by using the window marked Questions. Simply type in your question and click Send. You can also tweet your questions to us at the handle @Cumulus Networks. With that, I'd like to turn this over to Jennifer.
All right, thanks, Beth, and good morning, everyone. As we dive into this, just a little bit of context. A lot of the discussion around the evolution of SDN has really focused in the early days around how do we do better models for network segmentation in data center environments. And the early problems that we were seeing around how do we essentially use overlays to drive programmatic control around network segments that traditionally were very much based on VLANs has now evolved into broader sets of questions around really driving hybrid cloud infrastructures. The Open Contrail technology really takes a page out of the book on many large-scale network technologies that have been used in large-scale internet and IPVPN technologies, and we'll talk more about that. But really, this discussion around cloud network automation is really introducing a lot of things to drive network as a service and layer 4 through 7 services as a service via open APIs and the agility of open source technologies. Open Contrail, for those that are not aware, is an open source project. The technology is licensed under the Apache v2 license, and we put this technology out into the community to really establish a mature solution for network overlays, driving network virtualization, and network service delivery. It is a technology that's agnostic to the underlying physical infrastructure, and we can support various models of network virtualization driven either by proprietary or open source virtual machine hypervisor technologies, as well as supporting things like Linux containers. We've published all of our open APIs northbound via REST APIs, and we've seen already customers starting to support very diverse and heterogeneous cloud environments. Both public cloud and virtual private cloud type technologies are now coming together in a much more federated environment across networks. One of the key strengths that we have with Open Contrail is that we've taken a page out of the book, out of many standards-based network technologies, so that we're not reinventing the wheel on how large-scale networks operate. But as we've addressed this new problem around network virtualization and X as a service in the cloud environments, we're able to quickly get into deployments and scale with very standards-based, interoperable, and mature open technologies. A couple of key points around differentiators for Open Contrail. For many of our customers, the key thing is really to accelerate the delivery of new business services, new applications, new value-added services for their users. So the accelerated time to market and time to revenue aspect is really about driving simplicity and making sure that we can quickly ramp mature technologies that are very scalable, secure, and resilient. A lot of what has been driven in IT has been around lowering costs, and of course from a both CapEx and an OpEx perspective, we want to drive higher utilization of existing infrastructure so that we don't need to throw out every piece of the existing network infrastructure, but more evolve to address the new challenges. At the same time, a lot of automation is about driving logically centralized management capabilities and centralized administration across a more automated environment, so that not only can we drive lower OpEx and use fewer administrators to drive larger environments, but also avoid things like retraining across our workforce. A lot of convergence is happening across not just network technologies, but now network, compute, and storage. And so opening up the network to programmatic control and this concept of programmability using automation and policy-based automation is a key tenet of Open Contrail. In terms of network insights, opening up aspects of the network for visibility, monitoring, and troubleshooting, as well as just application and user-level flow data is a key piece. And this allows, obviously, a lot of the administrators, as this converged model evolves, to really understand what's going on, either per virtual machine or per virtual network. And then finally, openness has a number of aspects, but in the networking industry, obviously we've always needed, in terms of routing and switching technologies, to interoperate. However, this aspect of interoperability between overlays and the underlays, and making sure that we can open up via well-behaved northbound REST APIs, really enhances what we're talking about here with SDN technologies. Some of the key differentiators and services that are often, missing in other types of overlay technologies, especially in the early days of new overlay technologies. Now this notion of how do we do distributed routing and switching in either a hypervisor-based host Linux system or even in a hypervisor-less environment, we have the ability to, with kernel modules down in each host, distribute a lot of the L2 and L3 capabilities into this vRouter concept. At the same time, we need to start to distribute and address some of the new issues in terms of how do we do IP address management when you have overlapping IP address spaces and virtual networks, floating IP and elastic IPs. How do you do DNS and DHCP? All of these issues around namespaces are new challenges that are being addressed in emerging cloud environments. Various aspects of load balancing, but in many cases now we're distributing load balancing capabilities and exposing load balance as a service APIs into a broader cloud automation framework. And then I address some of the areas around group-based policy and how do we automate that, how do we distribute secure tenant isolation type capabilities, how do we inject gateway services and expose much more granular monitoring and analytics information to the network administrators. The notion of service chaining is also one that comes hand in hand, and many of our large-scale customers are also very interested in evolving the paradigms they have around both physical and virtualized services within the overlay. So we've worked very hard on using our control plane technologies and tying in various services as well. And then finally, this notion of introducing open standards-based overlays without any compromise points to a lot of the work that we've invested in terms of how do we create an elastic architecture with this overlay in a way that scales up and down very elastically and make sure that there's no single point of failure within the architecture. The other aspect of OpenContrail, when we made the solution generally available, we released the source code under the Apache v2 license and put all of our source code out there in a single GitHub source code repository, which essentially is a single master repository for all of the source code. The process also in terms of lifecycle management as well as ongoing management of OpenContrail as a project has some non-technical aspects where we've established an OpenContrail advisory board made up of our partners and customers and key industry experts in the field in driving community efforts. We also have a growing developer community, and we've seen partners and customers actively contributing back, doing a pull request on GitHub and actively contributing back some of their innovations into OpenContrail. Our bugs are publicly out there in terms of a launchpad capacity. End customers as well as obviously our Juniper team are filing bugs, and that is all very transparent. And then finally, obviously, a lot of the documentation and best practices, et cetera, are being put out there from a user community perspective. We've driven things like last month, the OpenContrail Users Group, where many of our customers who are already in deployment are sharing a lot of their best practices and lessons learned and operational diagnostic best practices, et cetera. So that aspect of agile software development and open community effort that the open source world has really pioneered is something that is benefiting us greatly from an OpenContrail evolution perspective. I'm not going to go into a lot of detail, but I think one of the aspects of using mature IP principles as well as leveraging technologies like IPVPNs makes this technology attractive to a wide variety of diverse customer segments. We've seen a lot of adoption across emerging customers, web, mobile cloud builder type customers who are doing either public cloud or virtual private cloud type capabilities using open cloud orchestration systems like OpenStack. And in the enterprise segment, as this model evolves, people are moving away from traditional models of IT and really looking at how do they deliver cloud-based self-service provision type services in this IT as a service model. So we've been working very closely with key enterprise segments as they've adopted also more cloud-like technologies and are looking for open source technologies that they can adopt without reinventing a lot of how they're doing data center management and automation. And then finally, in the carrier space, we've been doing a lot of work with many of the global Tier 1 and Tier 2, Tier 3 carriers as they take this notion of cloud computing and agile software delivery and try and drive innovation in their core businesses under things like network functions virtualization, where here we're not talking about the classic database applications, but more applications and services that are core to the telco cloud, things like security services and layer 4 through 7 services, CDN services, caching services, that kind of thing. And they're really looking at adopting a lot of the best practices in the open source community because they're really now getting to this model of how do we drive business agility and quickly enable new managed services through a self-care portal. So that evolution takes some time, and obviously each of those segments are quite distinct in their needs. A lot of what the overlays are doing has to work obviously very well in concert with the rest of the network infrastructure. And so in this, we're looking at things like layer 2 gateways where we can start to terminate encapsulation types directly in a top-of-rack switch. And start to federate these environments across both virtualized environments, bare metal environments, et cetera. So one example in this next slide, evolving standards like OVSDB, which really allow the controller to share configuration and control information to a top-of-rack switch, and obviously many third-party top-of-rack switches are starting to support OVSDB. This is a type of insertion point for something like Contrail's controller to communicate with the Cumulus top-of-rack switch, other third-party switches through standards-based and industry, vendor-agnostic protocols. That allows us obviously to create a transition environment so that customers who have a mix of bare metal servers as well as virtual machines and physical workloads can now look at this holistically as a joint solution. One of the key things in terms of more mature enterprise and carrier segments is that they don't have a greenfield environment. So another key aspect of network evolution is how do we federate the traditional environments, which traditionally are not based on overlay technologies and virtualized environments. You may have legacy layer 2 storage keep alive, and then evolving, we're seeing a lot of uptake for this model of a flat layer 3 fabric in a large scale out data center. And in that environment, once again, you have multiple use cases that need to be addressed, not just the interconnectivity between physical and virtualized workloads. You have a combination of virtual machines based on proprietary hypervisors, as well as emerging open source hypervisors, and increasingly a lot of interest in Linux containers and how we can essentially present those workloads as just an extension of the virtual networks that are managed by an overlay controller. Similarly, you have a mix of bare metal servers and storage in the IT environment, as well as a number of physical and increasingly virtualized services appliances, layer 4 through 7 services like firewalls, load balancing, IPS, threat management, DDoS services, et cetera. Finally, outside of a customer's data center environment and multiple data centers, we have the expectation that customers can federate their virtual private cloud workloads into heterogeneous public cloud environments, whether it be AWS or Google Compute Engine or Microsoft Azure. And many of our customers want the flexibility to essentially be able to federate different cloud environments in addition to federate workloads within their virtual virtual private cloud environments. So as we make this transition and migration, it puts more emphasis on how do we enable interoperability and robust control planes that essentially can allow these environments to peer, but still essentially have logically one converged environment. This is sort of up the alley of what core networking folks have been doing across the internet. However, many of the new problems that are expected by the application and cloud tenants are around the pay by usage and self-provisioning of those services without any delay and without filing a trouble ticket. And that gets us back to the imperative for large-scale policy-based automation in a way that doesn't expose all of the complexity of device-centric CLIs and network configurations. Just one example, we recently deployed a very large enterprise SaaS customer who in this case had deployed an OpenStack-based virtual private cloud. They had built out a CLOS infrastructure in their data center environment, but the use case for them was really around Hadoop analytics on bare metal servers. And one of the key aspects and key criteria for them was obviously large scale, but also the ability to do access control and secure multi-tenancy within their virtual private cloud environment. We're sharing many of the use cases of OpenContrail deployments. We've also seen many customers, as with this customer, contribute back very actively into the community and share best practices and test plans and evaluation criteria, et cetera. With that, I'll hand over to Mina to cover the next section.
Thanks for an awesome introduction, Jennifer. I'm hoping, or at least being sure, majority of the webinar attendees want to get their hands on some open source code here from OpenContrail to deploy and start playing with OpenContrail. As a quick intro for folks who've never heard of Cumulus Networks or are not so familiar, I'll take a couple of minutes and give you a quick sort of short overview. In order to automate and manage the cloud deployments that Jennifer just described, and also build and migrate to the modern data center blueprint, we believe networking has to become an enabler and no longer be a gatekeeper. And by fundamentally disaggregating the hardware and software, we're able to provide customers with the new concept of networking with choice. And customers can now choose to deploy a variety of hardware and get the flexibility and cost savings needed to drive business on demand, similar to what operators have done with compute and storage for decades. So Cumulus Linux is Linux, and being Linux, a Cumulus Linux powered bare metal switch drives like any other Debian system you've ever used. There is no special command line interface or shell dedicated to switching, routing, and other network operations. Fundamentally, that means you're transparently accelerating the Linux data plane while preserving a pure Linux control plane and empowering a wealth of orchestration and management tools that already manage your servers, virtual machines, and other appliances. Now, something for like a similar model to work where a switch can be treated as a server, we built ONI, which is an open network install environment, as a bare metal provisioning mechanism. Think of this as an enhanced Pixie bootloader, which helps you standardize and also increase adoption across the board for all ODMs or bare metal hardware manufacturers, also known sometimes as white box switches. As a continued effort to help the industry adopt this disruption, we've contributed ONI to Open Compute project. We also use Quagga as our primary routing protocol suite and have made several enhancements to the routing stack and consistently pushing it upstream as part of our open source contributions. Our engineering teams and customers have created several methods of automating and building zero-touch provisioning scripts so that the end-user experience is very similar to a server using a standard Linux interface. I think everyone sees the message here. All I would enforce here is a policy of no vendor lock-in and having the capabilities built in for sort of bridging the NetOps and the DevOps world for higher operational efficiency. I'll skip this one in the interest of time so that we have more time for Q&A later. So once we laid the foundation for a robust, scalable, and easily manageable sort of an L3 class underlay network, we added platforms providing support for VXLAN to enable physical and virtual network coexistence, platform debugging, visibility support, etc. Today, we have over 19 plus hardware platforms to our HCL, and we provide integration to SDN overlay controllers such as OpenContrail and orchestration engines. We believe that we will continue to focus on delivering the right set of solutions for operational simplification and higher efficiency. We maintain a very active HCL on our website, similar to our pricing, and believe that transparency is a key philosophy for us. From a platform standpoint, we support both x86 and PowerPC CPU architectures with Broadcom switching ASICs. Trident 2 hardware is the minimal requirement for any VXLAN support if you're thinking of integration between OpenContrail and Cumulus Linux. So one thing that I want to bring up, I saw a tweet yesterday. You don't have a platform if there isn't any apps in an ecosystem. And Cumulus Linux is a platform. And by truly unlocking the power of having this open networking ecosystem, we're able to build a variety of solutions as applications and network services running on Cumulus Linux. So because of the flexibility at every tier, you can build your own stack with a massive amount of density in terms of hardware needed to create a large L2A IP fabric with an overlay such as OpenContrail, and then have the plugin integrated into OpenStack for an end-to-end orchestration and automate it completely with a tool like Puppet or Ansible or others. So let me dive into a few specifics of the VXLAN support, which helps the integration with OpenContrail. We have customer implementations in production that have Cumulus Linux as an underlay fabric. But one of the use cases that we are targeting here is where Cumulus Linux peers with OpenContrail to provide wire rate L2 gateway services. Now, you heard from Jennifer that Cumulus Linux supports the network virtualization edge function by implementing a layer 2 gateway VXLAN overlay scheme and terminating the virtual networks and hardware using a VXLAN tunnel endpoint, or also referred to as VTAP. In particular, Cumulus Linux can initiate and terminate the tunnels in hardware. Today, the support for Cumulus Linux is available since our 2.0 release, early Jan 2014. We were able to leverage the existing VXLAN data structure forwarding logic, and also augmented by working with the Linux community for a speedy integration of VXLAN and Cumulus Linux. So this allowed us for not only flexible, but a rapid controller integration through the OVSDB server. So to explain sort of like a quick data flow here, the data flow is between the controller and the OVSDB server, and then the OVSDB server actually talks to the VXLAN configuration and IP route 2, and then which then talks via NIT-link to the VXLAN driver and the bridge forwarding database and the VXLAN bridges in the kernel. So one of the pieces that's unique about Cumulus Linux here is the operational simplicity. We can leverage a script to have the complete zero-touch provisioning of Cumulus Linux from the underlying hardware and register to the controller. So once the bootstrapping is actually done, all the configuration is in the controller, and you won't need to touch the VTAP. So why work together? Why OpenContrail and Cumulus Networks? We have a shared vision of open source, an open framework to allow customers and the community to grow. It is a very complementary offering with a high value and large cost savings for customers trying to build new architectures of loosely coupled integration versus a proprietary stack without compromising on the robustness and feature set that they desire. So, there's several use cases in how you can deploy OpenContrail and Cumulus, whether it's just an underlay fabric or if you're using VXLAN and actually driving it towards an L2 gateway kind of a setup. We're very excited about the customers that are already deploying us together and have us in production. And what we want to do is there are several myths also in the industry about how these overlay networks impact the data center. And we thought it would be useful to help address them up front for a couple of minutes. And for that, Jennifer?
Sure. So a couple of myths, there used to be a lot of question about is there a role for overlay networks, and I think as large-scale cloud providers started to be more transparent about the way that they're driving web-scale elastic architectures for their clouds, those started to not be a question anymore. The high levels of automation and making sure that we can do that without any compromise in performance and scaling and interoperability has been a lot of the focus of the efforts around OpenContrail. We put numerous blogs out there to show both near wire rate throughput performance, as well as the scaling of various aspects of the solution in terms of number of vRouters per control nodes, as well as number of projects and database type entries, to make sure that there is no bottleneck in the system and that we're fully interoperable with existing physical network standards, primarily IPVPNs, where we're able to reuse the notion of VRFs and provide routing instances per virtual network to make sure that we're being very efficient on how we do group-based policy and policy-based automation. The second area, and so that first one is really there's an increasing amount of data. Even our customers and partners have proactively shared a lot of the data that they've learned as they've tested out various overlay alternatives. So we see that as, as the industry matures, people are really making data-driven decisions around the requirements for their clouds. Secondly, from a performance perspective, there are some unique needs for the types of carrier-type applications where, applications, primarily stateful applications, which are very low latency, small packet size environments, are also looking for, incremental performance requirements. And we've also issued, publicly a lot of the performance testing that we've done there to optimize performance for, for instance, mobility-type applications in a carrier-class cloud. The standards-based work that the technology for Contrail is based on was co-authored by Tier 1 carriers who were really looking for how do we address issues around secure multi-tenancy and access control in virtualized environments in a way that is not tied to proprietary vendor technologies. And how do we do that in a way that day one works with large-scale layer 3 gateways, like Juniper's MX and many others that are standards-based compliant to IPVPN technologies, which happen to run the majority of mission-critical traffic across large-scale networks today outside of the data centers. So we pull that technology into the data center so that we can address a lot of the concerns about do we have to wait another 5 years for this technology to mature. We're essentially pulling the edge of a secure multi-tenant network into essentially the hosts, the Linux hosts themselves, so we can stretch that network edge in a way that is based on mature protocols. Secondly, the ability to troubleshoot the network and to get visibility across both the physical underlay as well as the overlay, and to correlate those independent of whose technologies are in the mix, is something that we've been working on in terms of how do we drive better diagnostics, how do we use topology discovery technologies like LLDP to look at and discover the physical topology, as well as map specific flows across virtual machines and across Linux containers, and aggregate that at the virtual network level. So from an operational perspective, this is huge in terms of enabling better troubleshooting and making the operations folks comfortable that they can scale these overlays with existing operational paradigms. So that's a key sort of piece of the evolution. And then Mina?
Yeah. So as closing, I think as next steps, we have several resources in planning, and it works to make the model more repeatable for customers as everyone's kind of learning, exploring, and adopting it. Stay tuned if you have any questions. Feel free to reach out to the OpenContrail and Cumulus Networks field teams, sales@cumulusnetworks.com. If you also want to get some hands-on time with Cumulus Linux, I would say sign up for our workbench. It's a completely automated environment. It's not a simulator. And it helps customers make that shift. This is a short webinar to get folks started, but I hope it was useful, and we plan to do a technical deep dive in the near future. So with that, let's get some of your questions answered. I see a bunch of questions coming in Q&A. So back to you, Beth.
Okay, super. Thank you, Jennifer and Mina. The first question is for you, Jennifer. Are you working specifically with any partner in the OpenStack space in order to have a complete solution for OpenStack users?
Sure. So yeah, we are gold members of the OpenStack Foundation and have collaborated with a number of folks driving OpenStack distributions. In terms of joint environments, we've with Cumulus, we've worked with OpenStack integrators like Marantis in deployment, and in fact, some of our joint customers are sharing some of their best practices openly as well.
Okay, super. Thank you. Mina, one of the next questions here, how do you see Cumulus Linux customers adopting network virtualization overlays?
That's actually a really good question. And so most of the customers, they're kind of hearing about the open networking model, and they're tending to adopt it. They're building large L3 clusters. And then their question turns out to be, well, how can I use some of these network virtualization overlay technologies and span across data centers because with the multi-tenancy requirements sort of driving that business use case. So what we tend to see is before it was a lot of POCs. I would say 2013 was curiosity, was POCs. 2014 has been a lot more adoption in terms of the interest picking up. We've seen a wide variety of interest in with a couple of customers. I think two of them, at least one I can mention, IIJ is a public reference for both OpenContrail and Cumulus Linux in Asia Pac, and several in US that we can't name yet. But we certainly are looking forward to kind of putting out some deployment case studies that customers can actually take a look at. But the adoption definitely has increased in 2014.
Excellent. Okay, that's great to hear. Jennifer, can you say something about OpenContrail's ability to utilize NIC performance versus CPU utilization?
Yeah, I mean, we've done a lot, and if you go to the OpenContrail blogs, we have a couple of blogs there that are very specific about the performance benchmarking and testing that we've been doing, including CPU utilization and throughput performance, and the setup is very specific there. So I'll refer folks to OpenContrail in the blog that one of our key engineers had done specifically on some of those questions.
Okay. Excellent. Jennifer, another one for you. If a customer chooses to implement another overlay solution besides OpenContrail, what are your typical observations there?
Yeah, so great question. I mean, the overlay space obviously has evolved, and lots of folks jumping into the space, over the last couple of years. One key differentiator is, with this movement of open cloud and open networking, a lot of folks are making a very key criteria in their RFPs, the ability to support sort of the open source model. And it's not necessarily because, just because of the transparency and the agility. They really like the growth of the community and the commitment to an open ecosystem that drives. So the proprietary versus open source is one key piece. I think the other thing, what we've really done with Contrail and the technology approach is really a large-scale distributed system and a full distributed routing capability in the Linux kernel, which then rolls up to address some of the aspects of simplicity and automation through a controller-based architecture. And at the same time, without any compromises on what we've done with large-scale secure networks in terms of driving IPVPNs across a virtualized data center. One of the other key things is a lot of folks have seen the network overlays as a key bottleneck and an area of unnecessary cost because extra gateways are being put in place to exit the overlay. In the case of Contrail, for instance, we can use the existing layer 3 gateway technology to terminate either VXLAN tunnels or GRE tunnels or UDP traffic directly on the gateway that is already there. And we use BGP as a control plane so we can communicate not only across our own controller nodes but also to the layer 3 gateways using mature standards-based protocols that are pervasively deployed across the wide area. So we use things like BGP to federate and horizontally scale without an upper bound, and that also allows us to, with large-scale distributed systems, to address a lot of the operational concerns like how do we do in-service software upgrades so that we don't have to have a lot of downtime. In a cloud environment, that's obviously unacceptable, so we need to make sure that we're supporting real-time traffic loads without any interruption and make sure that there's no single point of failure in the architecture. architecture. The ability to interoperate with mature existing technologies that support IPVPN is a major differentiator, and it has allowed many of our large-scale customers to move into deployment very quickly with confidence using technologies like Contrail.
Okay, well, that's excellent. Okay, super. Mina, I'm going to ask you the next question, or maybe both of you here. Juniper announced the OCX platform recently as an open switch with support of ONI. Does Cumulus Networks support this new switch?
So that's actually a very good question. So, Cumulus Networks, we've sort of been, the industry is calling us sort of the trendsetters in this space. We definitely have been a leader in terms of getting the industry to adopt more of the open networking model, and we're very excited to see Juniper adopt this change as well. In terms of the hardware platforms itself, it purely depends on customer demand. If it is a OCP certified hardware, I don't see a reason based on the customer interest and the drivers, for us to actually support a specific hardware. As you can see, at CL, we have almost 19 platforms, and we have several platforms in every release that are being considered. So I don't see a reason why we wouldn't consider at some point if this is an important hardware for us to support based on customer demand.
Excellent. Okay. Thank you both, Jennifer and Mina, for your presentations and for the answers. We're out of time now. I want to thank everyone for your participation. We hope you found this presentation on accelerating SDN applications with open source network overlays useful. Well, I'd like to ask you to provide your feedback via the follow-up email that we'll send, and also would like to invite you to register now for the next webinar, which is January 14th, and it's called Making the Switch to Bare Metal and Open Networking. Or for an introductory session on Cumulus Linux, you can join a webinar that we do every Thursday morning called Coffee with Cumulus. Details about those and on-demand webinars are available at cumulusnetworks.com/webinar.
And for all the questions, looks like there's still a lot of questions coming in Q&A. What we would love to do is we'll respond to all the questions and create a blog so that none of your questions remain unanswered.
Perfect. With that, thank you all for your time today, and thank you again for participating.